students. So we will start with a new topic today, and we will start with tree data structure. Okay, we can say it's an extension of linked list. So we covered linked list, and we have discussed various operations on linked list like searching and inserting a node at the end or at the beginning or at the mid of linked list. So we have done all these things. Okay, so keeping the linked list concept in mind, we can extend and create a new type of data structure that is called tree. So we will first understand pictorially what a tree is. Then we will move towards how to implement a tree in computer science or IT using a high level language. Okay. So first of all, we will just understand what a tree is pictorially. Okay. So we can say a tree is a type of data structure which also consists of nodes. Like linked list, keeping the idea of linked list, suppose linked list looks like this, isn't it? Pictorially we say linked list look like this, where this represents one node, isn't it? And all nodes are connected how? Through the next value. Okay, a node has two fields. One is data, another one is next, which is a pointer to the next node. And this way these nodes are connected, and we call the connected nodes as a linked list. Now if we modify the structure, now suppose nodes are arranged this way, then we call this as a tree. So this is a basic structure of a tree. Okay, where a node, this node is called a parent, and the nodes which it is connected to, okay, we know the structure of a node. Don't you remember? This is next, this is data. So this is a node. So these round structure are nothing but nodes. I am just representing it to make it easier. Okay. So these are, this is left child, and the right side connecting node is called right child. So this is the basic structure of a tree. Okay. Now moving on to an important terminology. The tree can be like this as well. Now this left child has another left child and right child. Okay. So this is the parent of this subtree. So for this entire tree, the parent of the entire tree, or we can say the starting node of the tree, is called what? Root. The starting node of the tree is called root. Root node. Okay. So the first node in a tree has root node. Okay. It is called root node. Okay. So these are the basic terminology. And the root has left subtree. This is left subtree, subtree, and this is right subtree. I hope you got the idea now. Okay. So a tree can be described as nodes connected in this kind of manner. Okay. In a hierarchical manner. What is this manner called? Hierarchical manner. Why this is called hierarchical manner? Because there is a hierarchy. First there is root, then there is these two child nodes, then there is this node. Okay. So this hierarchical are labeled as level. This is level 1, this is level 2, this is level 0. Okay. So these are termed as levels. Hierarchy means there is a ladder, one after another. So in the top hierarchy we have root, then we have next hierarchy. It depends upon the size of the tree. So the length is defined by the size, or we can say the levels are defined by height. So this is called height h0, h1, h2. So this tree, this particular instance tree that we have taken has height equal to 2. Height equal to 2. So The number of levels defines the height of the tree. This is very important. Pay attention. The number of levels defines the height of the tree. The root node is always present at height 0. So the root node is always present at height 0, h0. This is h1, this is h2. Suppose I have this node. This is also a tree, right? Because it has left subtree, right subtree. Okay. Otherwise, the smallest tree consists of one node which is a root node with no children. Then also we call it a tree. Okay. So tree consists of nodes connected in this manner. Okay. The starting node of the tree is termed as root node, and it turns down in a hierarchical manner, having a left subtree and right subtree. Okay. And the number of level define the height of the tree. Okay. So this tree has height what? Now if I add this, the tree has height. This is 0, 1, 2, 3, 4 levels. Okay. So this is h3. So height becomes 3. Okay. So now taking an example, we will define all the terminology taking the field example, need and field example. Okay, I will take a small example. Suppose this is a sample tree. So root node, this is a root node. Okay, this is the left subtree, this is the right subtree. And what is the height of the tree? h0, h1, h2, h3. So height of the tree is 3. Okay. Now you may ask, ma'am, you said that tree has root and it is connected with node in a hierarchical manner, that is one by one manner. But why you are connecting always 2 nodes? See, we can also connect 3 nodes. But it is beyond our scope. Why? Because we are focused on usually binary trees. What is binary trees? Binary trees means a node which is connected to max 2 nodes, which is connecting maximum 2 nodes. So we can have either 1 or 2 nodes. So this is a valid binary tree. This is a valid binary tree because it has said max 2 nodes. Minimum you can have 0 nodes as well. This is also a binary tree, but this we call as a complete binary tree. Why complete? Because it has exactly 2 nodes connected to it. It has exactly 2 nodes connected to it. Okay. So this is also a valid binary tree. This is also a valid binary tree. This is also a valid binary tree. If I connect like this is root. Is this a valid binary tree? No. This is not a valid binary tree. Why? Because maximum you can connect 2 nodes, not more than that. I have connected 3 nodes to the root. So this is not a valid binary tree. So here, when I say trees, you have to by default take it up as binary tree. Okay? When I say tree, we assume it is a binary tree. Okay? So the height of this tree is h. Height is denoted as h. H is 3. Okay? So these are the terminology. So now let us discuss a few things in case of binary tree, which is important, which is very, very important. You must remember. Since you have known what is height, so we will relate in binary tree. Given a height h and number of nodes n, we can relate that what is the height given, what is the maximum height or you can say what is the maximum number of nodes in terms of height we have to find out. Okay. So the maximum number of nodes we can have is 2 to the power h plus 1 minus 1. This is the formula. You can verify it as well. Suppose height is 2. What is the maximum you can have? In height, 2 means this is 0, this is 1, this is 2. Okay? What is the maximum number of nodes you can have? This much, right? The count is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 7, isn't it? So, is this compliant to the formula? Yes, we can check. 2 plus 1 minus 1. Since height is 2, to 2 to 3 minus 1, which is 7, which is perfectly fine. Okay, you can verify this as well. So, the maximum number is 7 when we have height 2. It cannot go beyond 7. Okay, so this is the formula that given a height, what is the maximum number of nodes present in a binary tree? This is applicable to binary tree. Pay attention. Okay. Now, similarly, what is the minimum number of nodes present given a height? Given a height, same case, if h is 2, what is the minimum number of nodes? What can be the minimum number? h0, h1, h2. So this can be minimum now. With this height, the minimum number, कम से कम नोड होने वाला ट्री क्या हो सकता है? ये है तो इसमें कितने नोड्स हो सकते हैं? 6. So this will be n minus h plus 1 always. So in this case h, let's see, n is 3. Is it h plus 1? N is 3. We are finding 3. Is it h plus 1? Yes, it is 2 plus 1, isn't it? So this is being verified. So yeah, it is perfectly fine. Our formula is right. Okay. So we found out that given a height, what is the maximum number of nodes? You can tell this by the formula. If I ask you, given a height, what is the minimum number of nodes in a tree? You can tell me. Why? Because of this formula. Okay. Similarly, given node, given number of nodes, how to find the height? Okay. So if number of node is given, then height of the tree is, minimum height of the tree is log 2n plus 1. Okay. Log 2n plus 1. That is the minimum height of the tree. Now what is the maximum height of the tree? Log 2n plus 1 minus 1. Sorry. Now what is the maximum height of the tree? That is n minus 1. This will be the maximum height. Okay. So given number of nodes. So suppose the given number of node is 7. So 1, 2, 3, 4, 5, 6, 7. Yeah, perfectly fine. So height, it is turning out to be what? 0, 1, 2. So height is 2. Let's verify whether it is falling into the formula or not. So log 2, 7 plus 1 minus 1. Log 2, 8 minus 1, which is 3 minus 1, which is 2, which is our height, isn't it? So it is falling into the formula, which is perfectly fine. Similarly, given n is equal to 7, which is this, what is the maximum height? What can be the maximum height? Maximum height can be like this: 1, 2, 3, 4, 5, 6, 7. So height is h0, h1, h2, h3, h4, h5, h6. So height can be 6. So here h is equal to 6, which is 7 minus 1, which is n minus 1. So it is also falling into the formula. So this is also perfectly right. So we have cross-checked everything. So given the number of nodes, we can find the maximum height of a tree, and we can also find the minimum height of a tree. Okay. So these are the 4 basic important formula you have to remember in case of binary tree. This is applicable for binary tree. So given height h and number of nodes n, we can find, given height we can find maximum number of nodes, minimum number of nodes. Given number of nodes, we can find maximum height and minimum height. Okay, got it? So I think you understood tree. So we will just revise what we in the introduction what we studied. This is an introduction class to tree and some basic terminology we discussed, and about few things like few formulas like given the number of nodes, the relationship between height and nodes has been provided. Okay. So a tree is consists of the tree is a data structure in which various nodes are connected basically in a hierarchical manner. Okay, it is connection of node in a hierarchical manner in which the starting node is called root node, and node is connected to n number of nodes. So depending upon the n number of nodes, we call them as binary tree, trinary tree or n-ary tree. If a root is connected to two child node, then we call it as a binary tree. If the root is connected to three child node, then we call it trinary tree. Otherwise, if it is connected to n node, in general, we can generalize it and say it is an n-ary tree. Here, we say it as a n-ary tree. Okay. If the root is connected to n number of nodes, then we call it as an n-ary tree. Now, what is the height of a tree? The number of levels in the tree, the hierarchical manner since the nodes are arranged. So the hierarchy is defined in terms of each level. So the number of level defines the height of the tree. Okay, and root is always present at height 0. So the numbering starts from zeros in case of tree. Okay. Then we studied about the number of nodes in binary tree given the height h in terms of its maximum and minimum values. Similarly, given the number of nodes, we can find height in terms of its maximum and minimum value. Okay. In the next class, we will study about how to traverse tree, and then we will go into the implementation of tree using C language. Okay. So that's all for now. If you have any doubt, we can discuss it in the Zoom class, or you can post it in the comment section, or you can directly reach me in my WhatsApp number. Thank you.